Let's start with the integral of cotangent of x dx. First, let us rewrite this into its simpler form, which would be cosine of x over sine of x of dx. And so, let u here be sine of x. The derivative of sine of x would be cosine of x dx. So, dx right here would be equal to du over cosine of x. And so, rewriting this would be the integral of cosine of x over u multiplied by value of dx, which would be du over cosine of x. This would cancel. And so, you are left with the integral of du over u. The integral of du over u would be the natural log of u plus c. And so, substituting u into its original form, we will have the answer of natural log the absolute value of sine of x plus the constant of integration. Let's start with the integral of cotangent squared of x dx. And so, we will transform cotangent squared of x into its trigonometric form, which would be this. Cotangent squared of x would be equal to cosecant squared of x minus 1. And so, by transforming this would become cosecant squared x minus 1 of dx. The integral of cosecant squared of x. Wait, let's just put this in the derivative. The derivative of cotangent of x would be equal to negative cosecant squared of x. And so, the integral of cosecant squared of x would be equal to cotangent of x. But since this is negative, let's make it negative cotangent of x. And the derivative of 1 dx it would be equal to x plus the constant of integration. The integral of cotangent cube of x. And so, first thing, we're going to factor out a cotangent squared of x so that we can transform this into this form. And so, this would become cotangent squared of x, cotangent of x of dx. And so, we will transform this 1. And so, this would be the integral of cosecant squared of x minus 1 multiplied by cotangent of x dx. And so, distributing cotangent of x on these two, we would have the integral of cosecant squared of x, cotangent of x, minus cotangent of x of dx. We can now split this integral into two parts. And so that we have that, we must focus on this first integral. Let u here be cotangent of x, and the derivative of cotangent of x would be negative cosecant squared of x dx. And so what we will have here would be, wait, let's just rewrite this. So this would be cotangent of x here is u, and cosecant squared of x and dx. This is here cosecant squared x and dx. So this would be du, but keep in mind there is a negative here. So just put negative outside. And so integrating this, we would have negative u squared over 2, which is the integral of u du, minus the integral of cotangent of x as we had solved earlier, this would be the natural log of the absolute value of sine of x plus c. Thus, the final answer of cotangent cube of x dx would be equal to negative 1/2 of u here is cotangent squared of x minus the natural log of the absolute value of sine of x plus c. Make sure to remember all of these answers because they will be used later. The integral of cotangent to the power of 4 of x dx. Wait, let me just rewrite the identity again. And so, the first thing again would be to factor out a cotangent squared of x. So this would be cotangent squared of x raised to the power of 2 of dx. Or for simplification, we can just do it like this. Cotangent squared of x multiplied by cotangent squared of x of dx. You can use either of those, but I will just use this. And so, transform 1 cotangent squared of x so this would be cosecant squared of x minus 1 multiplied by cotangent squared of x dx. And distribute this. And I will be splitting this into 2 parts again. So this would be the integral of cosecant squared of x cotangent squared of x dx minus the integral of cotangent squared of x dx. And so, let us focus first on this first integral. Let u here be cotangent of x. Derivative of this would be negative cosecant squared of x dx. For simplification, we will just rewrite this. So this can become the integral of cotangent squared of x multiplied by cosecant squared of x dx. And so, substituting this value, cotangent squared of x, this can be u because it is cotangent of x. So, this can be u squared cosecant squared of x dx is du. And just put the negative sign outside. And copy the rest. And so by integrating this, we would have the integral of u squared would be u cube over 3. And the integral of cotangent squared of x dx, as we have solved earlier, it would be equal to negative cotangent of x minus x plus c. And so the final answer would be negative 1/3 of u, which is cotangent cube of x. Negative times negative would be positive cotangent of x plus c. The integral for cotangent to the power of 5 of x dx. Once again, factor out 1 cotangent squared of x and transform this according to its identity. And distribute this. Wait, this should be dx. And so, focusing on this first integral, let u here be cotangent of x. Du would be negative cosecant squared of x dx. And so we are left here with is cotangent of x cubed. This would be u to the power of 3 cosecant squared of x dx. This should be du, and just put the negative sign outside and copy the rest. And so the integral of u cube is u to the power of 4 over 4 minus the integral of cotangent cube of x. This would be negative 1/2 cotangent squared of x minus the natural log of sine of x plus c. Thus, the final answer here would be equal to negative 1/4. U here is cotangent to the power of 4 of x plus 1/2 cotangent squared of x plus the natural log of sine of x plus c. For the final problem, the integral of cotangent to the power of 6 of x dx. So, factor out cotangent squared of x again. And transform this. And distribute. And so by focusing on here first, let u here be cotangent of x. Du right here would be equal to negative cosecant squared of x dx. So this would be the integral of u to the power of 4 multiplied by negative du minus the integral of cotangent to the power of 4 of x dx. So we'll just put the negative outside here. And so what we have here would be like this. This would be negative to the integral of u to the power of 4 multiplied by du, which is the same as earlier. The integral of u to the power of 4 is u to the power of 5 over 5. And the integral of cotangent to the power of 4 of x, as we have solved once again earlier, it is equal to negative 1/3 cotangent cube of x plus cotangent of x plus x plus the constant of integration. And so the final answer here would be equal to negative 1 over 5 of cotangent to the power of 5 of x plus 1/3 cotangent to the power of 3 of x minus cotangent of x plus the constant of integration.